Hello everybody, this is Mark again with the stability analysis in XFLR 5, and let's cross our fingers this time around so that we don't have, and I hope we don't have any technical problem this time. Before we step into the actual XFLR software, again, I would like to show you that there's this piece of PDF called about stability analysis using XFLR 5 available on the internet. You can just Google it, and it gives you a lot of fundamental knowledge about what we're going to do today. Especially, I would like to turn your attention to the different static stability modes, response modes. So there are different. At least you should know that there's difference between static and dynamic stability. There are different aerodynamic modes. For example, Fugoi. There are short period modes. There's roll damping modes. There are Dutch roll modes. All of that you can find all of the description right here. It will be these are much better description than what I can provide you speaking in front of computer screen. And of course, if you, like me, someone who does not pay attention to his control lectures, here are some descriptions about dynamic responses, and then damping ratios, and then you can learn all about the Rue-Lucas graph. A little bit of intro, gives you sort of a warm up or refresher about what you have already forgotten in 301, 364, and 421, and so on. With that, let's go ahead and get started. So this is what we have left off from last time, and let me do a full screen for you. Somehow, I think there's a piece of software that's making my screen, the bottom of the screen, red, so don't worry about that. You probably won't see that in your actual software. So I think you already familiar yourself with all of these things in XFLR, so all of these menus. So let's go ahead and go to, so we'll click on one of the planes, and then we will go to analyses. We will hit on the define a stability analysis. Oh, before this, the criterion before any of these stability analysis is that you have a stable plane, which I'm assuming you already know that require negative slope on the CM alpha graph as well as the CMCL graph. So going back to this, so there's only one type of analysis, which is the mixed 3D panels field M2, and then you will enable viscous analysis, and then the flight attitude. If you don't have anything to do with your beta and then phi values, just keep them 0, which should be good enough. And then, so the ref dimensions, keep them in the second option, which is the wing planform projected on the XY plane. Nothing to mention about there. So mass and inertia. So again, I would encourage you to use the plane inertia that you have already defined in your airplane, unless you want to see how does these top level properties of your airplane affect your stability of the airplane, So now this is my my airplane weight, and I can change them incrementally, and then I can see what happens. And that's for the mass and the inertia. So I'm gonna keep them use the plane inertia that I have defined previously for now, and then let's move on to control parameters. So when you are defining the airfoil flaps as well as the wing and tail incidence angles, the XFLR will keep a note of that and track your designs in here, so that the file So the program knows that I have a wing tilt of somewhat degree, and then elevator tilt degree, and elevator flap degree, and all of that. It knows, and it will keep them right here. And then we're not gonna worry about the gain for now, and I'll show you exactly what they mean, and they are quite important for your later analyses. And then for the aero data, again, same thing as before in the aerodynamic analysis, an extra drag, the same thing. So we're gonna hit save. And then we're gonna hit, T7 VLM2 demo, and we'll hit OK. So this is a single, I'm gonna show you which is a single analysis. So we select the sequence, and then we'll enable both these options, and then we'll hit analyze. And that was really quick because it was a single analysis. But what's important is that you can see here that the operating points falls on the lines of the T2, which is the aerodynamic analysis. So this is just a one single operating point. And then we can go ahead and move on to this plane, little plane right here, and then we'll show the airplane. And then, so for example, so over here, I will, in the Mac OS version, I have plane analysis as well as the stability. Once I click on the airplane icon, and I will see this button. And then, so another thing is that once you performed your T7 analysis and you go to your operating point, you will see all of these stability derivative informations with all axes, and then these are very useful informations for to determine the stability performances of your airplane. So I'm just going to show you. You can find them all here. Just click on one of the operating points. But right now I want you to pay attention to this stability window right here. So let's start with the longitudinal mode. So the type 1, so most section is the type 1. So this is the short period mode. Then the plane will start from an equilibrium point and try to return to its new equilibrium states. And then type 2 will be the same as type 1. So we can see that if we hover our mouse over these boxes, we can see the definition of the symbols, and then over here that we can set the time step. So because type 1 and type 2 are short period modes, so we're gonna set their time steps fairly small, and we can adjust the speed and then the amplitude of the oscillation that we are going to intentionally introduce to the airplane. And then we'll hit the animate button. You can see because of the it's a short period mode, it will recover fairly quickly, and thus we have demonstrated that this plane is stable. And then let's go ahead and go to the fuel-going mode, which is depth mode 3. Because this is a long period mode, if we have the same time step, the plane will behave very differently. Will behave very slowly. So what we would like to do is to change the time step, right? So we can restart the analysis, restart the animation, and you will just recover really quick, fairly quickly. And then, of course, I think the fuel-going mode is probably the best to look at them from the side. And then we go back to the stability panel. We'll restart the animation, and then we'll animate, right? So you can see that the airplane is oscillating, but eventually returns to the origin point. So that means the plane is also stable in the fuel-going mode. And then mode 4 is same as mode 3. And then we'll animate. So, these planes are are stable, showing a stable behavior when the input is applied, so that is always good. And then we can move on to the lateral modes. Again, you will have four different modes. Actually, I don't know what mode 1 is exactly, but I believe it's the same as mode 2. But mode 2 is the Dutch roll mode. So again, these are the same. You can hover them to see the information, and then you can same set of dials. Sorry, mode 1 actually, never mind. Mode 1 is not the same as Dutch roll mode. So this is the roll damping mode. So this is a very quick short period mode. So 0.01 or maybe 0.005, and then we'll animate. Right, so the plane will just recover 0.05. This works for me to just readjust the amplitude, and it will animate. So yeah, the plane will recover, right? So that shows that if the plane, if a gust of wind that raises the one side of the wing, and the plane will return to its level flight. And then mode 2 is the Dutch roll mode. So we'll select mode selection number 2, and then we will animate. But again, this is a small short period mode, so a smaller time step will show the plane's behavior on the yaw, as well as the pitch bank. And then finally, you have type 3, which is basically the same as type 2. And then finally, you'll have the spiral mode. Spiral mode for most airplane is not stable unless pilot input is required, and this is a lot of long period mode. So you can see that if I have a small time step, the plane is just slowly moving away, right? So if we give it a larger time scale, 1 second, and then we'll change that, and then we'll restart and see ya. So boom. So this is the kind of cool animation that can tell you what you're playing, the plane that you have designed with its current aerodynamic configuration, as well as the inertia. How does the plane will probably behave in the real world? So these are some of the cool animations that you can play around with. But for actual analyses, let's go ahead and look at the rule locus graph. So on the menu bar, you will see this axis with 4 dots. So you can go ahead and tap in that. So again, so this is the rule locus graph of the spiral mode that we have just selected. And if we go to the other modes, hold on a second. So if we go to longitudinal, right? So you can see that in different dynamic modes. Because in longitudinal and lateral, how do I say that? Those are different set of sort of governing equation of your airplane, and then in the longitudinal mode, usually you will see two sets of eigenvalues, and they're the complex conjugates of each other. But the idea is that you want to see the value on the real axis and then the imaginary axis. So the more negative the number it is, the more damped the oscillation is. So that means these guys are more damped, but they also have a larger oscillating frequency. So these oscillations will be damped out really quickly. So these are the short period mode, and hence these are the long period mode. And also you can see that they have really small negative real parts of the eigenvalue, and that's why they take a little while to converge, but eventually it will. And going back to the lateral modes, right? So we see two different sets of eigenvalues, or I mean, this one lies on the real axis, so it's just its own. But you can see that this is the short period mode, and then this is the long period response mode. This is representative of the spiral mode. So this is how you can figure out the eigenvalues, and then the exact values, I forgot to tell you that they're all right here. So that's how you can get the eigenvalues and then the complex plot of your aircraft system. So and then finally, let's go ahead and take a look. Oh, one more thing we can take a look at is the stability time response by clicking this curvy graph on the menu bar. And then, so one of the things we can look at is the initial condition responses. So for example, I give so V naught is just like, the initial velocity of the airplane, like say a gust of wind or something like that. And then we can go to mode 1, and then we can go ahead and hit we can define the delta T, which is the, I think everybody knows what delta T is about, and then we can set the total simulation time. So we go ahead add. So this one is clearly not stable. And then we'll do another one. We hit the add button. The add button, this one is clearly not stable. But if we go to longitudinal mode, if I hit add, you can see that I give a 1 feet per second of initial velocity. In the initial velocity, we can the plane will the plane's behavior will oscillate a little bit in the U direction, and then eventually will die down. But the simulation only lasted for 30 seconds. Let's do this again. Different modes we can play around with, right? So yeah, so you can dig around in this modes and then investigate the time response of that is. Oh, by the way, I would probably recommend. Oh, never mind. We'll talk about this a little bit later. So these are the three useful tools for you to investigate the stability of your aircraft. And also this is a lateral mode. You can do the same thing. But coming back to the analysis definition table, and I'm going to show you these two things that I kind of skipped earlier. So this is a really important part of your XFLR stability analysis. So what I have showed you early on, using this single point analysis is that this is not particularly useful. Well, this is a very useful operating point, but if I have control surfaces, for example, elevators and rudders that I want to deflect, and I want to see how does that control surface deflection shift my airplane along these curves that I have defined along for my aerodynamic analyses. So what we can do that by defining a new stability analysis, and then we keep everything else the same. Of course, if you want to just go ahead and jump to these control parameters, you can skip everything that I just mentioned, and then set up a gain over here. So for example, I would like to see if I move my elevator, and then how does that elevator deflection put my airplane on the curves? So for example, I'm gonna set a gain. So the gain is delta between each operating point. So for example, I have set a gain of 0.5 and then 0.5. Oh, not this one. This is elevator tilt. This is the instance angle. So 0.5. So between each operating points, the elevator deflection will change 0.5 degrees. So we'll hit save. And then we need to enable the sequence, and then we will start with start and end a number just like we did before. And also we can probably, we can also change the delta to 1. So let's start with, let's say, negative 10 degrees to positive 10 degrees of how do you say that? The elevator deflection angle. So we'll hit the analyze button, and then we can see that we have generated a bunch of operating points. So for one interesting plot that we can see is the CM versus V graph. So for example, this operating point, so again, if I expand this, that my operating point is moving along this graph, and then hold on a second, what is going on? Okay, so I just reran the analysis. I guess when I was inputting this parameter, the software didn't take that number in when they hit the analyze button, and then they only calculated from 0 to 10, and then once you hit the analyze again, you will see the negative 10 to 10 showing up in the full range. Let's change this graph to CL versus alpha, because I think that is a more interesting graph to look at. So we'll hit CL versus alpha. So yeah, so as you can see that as I change my elevator deflection angle, basically I'm raising my plane up, right? I'm pitching my plane up by deflecting the elevator upward. Again, I'm gonna go back to this analysis panel again. I think this is good to mention that the plus sign means the trailing edge is going down. So the fact that I have a set of positive gain and then with a negative multiplier right here, meaning that I am decreasing the trailing edge, I'm moving the trailing edge down, but because elevator is a sort of inverted airfoil, the elevator is actually moving up physically, so it's pitching the airplane up. So hope that is a good enough explanation. And as you can see that I want you to pay attention to this V versus CM graph, that at this point, at about, let's zoom in a little bit, so we can see that about this neutral point, about when the elevator deflection is 0 degrees, and the plane is designed in such a way, I'm not sure if it's the most quote-unquote aerodynamic efficient way to do things, but this is the way my team decided to do it, is that when no elevator input is given, the plane will have no pitch up or pitch down tendencies. But once we start giving more deflections, then the plane will start pitch up and pitch down. As you can see that if I keep pitching my airplane up, I'm pitching my airplane up, not only my lift coefficient increases because of the drag increase as well. So if we look at the CD graph as well, edit, not polar edit, we want to edit a graph, define graph settings, we can go to CD. Again, XFLR underestimates drag, but again, it's a good estimation. So as I pitch the airplane up, my lift coefficient increases, my drag coefficient increases, and in turn, that will slow my airplane down. And also if you pay attention to, you know what, this is actually, you know what, let's keep the CMCL graph as well. I like that graph. That's a nice looking graph. So the y-axis will be CM and versus alpha. So okay, right. And then that kind of goes to show you that, you know, again, this is also proven. My operating point is also proven by this CM versus alpha graph, right? So that at this point, the angle of attack of my entire airplane is about 4.5 degrees to 5.5 degrees, and there's no pitching tendencies, pitching moment. So, and again, at each operating point, you still have the freedom of choice to investigate different type of dynamic modes if you so choose. And then finally, what I will say about the analysis modes is that you go to edit. If you don't want to change these parameters, you know, another way you can do is to go to the mass inertia panel and then change these top level inertial properties as you wish by setting up the gain and then the delta and then the maximum and the minimum value. So the maximum minimum value is how much the delta will be multiplied by this maximum and minimum value. You know, one thing that I can easily think about is how would my total aircraft weight, you know, if I set a gain to adjust my aircraft weight within a certain range, how does that change my cruising speed, or how does that change my lift to drag ratio during the ideal operating conditions? Of course, you can change the COF of center of gravity of these, and also change the mobile inertia of your airplane to see the stability responses. Yeah, so this is pretty much all of the everything that I have for you guys for XFLR XFLR5 stability and control analysis. So thank you very much. Oh, one little bonus is that if you choose to do the stability analysis by adjusting the gains of the control parameters, if you go to the rule locus plot, you will see something that looks like this. And then if you go to all of your operating points, and you will click on all of them, and you will see this is the rule locus of this dynamic system under this condition, under this gain applied. So like if you and then if you move along your operating points, you will see them. You will see this rule locus move along the complex plot. Oh, actually, this is exactly what the gain is doing. Like as you apply the gain, and then the rule locus will move, and this is where your breakout point of your rule locus, and then you will start to grow out on the imaginary axis. Oh my god. But yeah, something I've way long forgotten in my control courses now is coming back to haunt me. But anyway, this is a little bonus for you guys, and I hope you guys like it.